Okay, welcome to the deep dive. Today, we're going to be talking about something that everyone interacts with, but probably doesn't know that much about:
Yeah.
file systems.
Invisible architecture.
Yes. So, when you go to format a drive out, you always see these options like NTFS, exFAT, FAT32.
Right.
What do they actually do, and why should you care?
This is like the shortcut to figuring out how to organize all of your stuff on your computer.
Yeah. And speaking of organization and stuff, this deep dive is brought to you by Stonefly. They've been doing
Yes.
data resilience and protection solutions
Yeah.
for over 20 years.
Right. And that's really important when we're talking about how our data is actually organized.
Yeah. So let's get started. What is a file system? What's going on under the hood?
You can kind of think of it like a library, right?
Okay.
I got a ton of books. You need to have a librarian and a way to organize it all. The file system is kind of like the librarian for your computer. It takes all the raw space on your hard drive, SSD, USB drive, and it organizes it into these manageable chunks. And it
Yeah.
keeps track of where everything is, like where each file is stored, what space is free. So when you go to open that document or that cat video or whatever it is,
Right.
the file system knows where all the pieces are.
So it's like the ultimate organizer. So it's not just a chaotic mess of data.
Right.
So the video we watched from Explaining Computers was talking about FAT, the file allocation table. And that's where it all started, right?
That's right. That's how Windows started. And FAT went through a lot of iterations. There was FAT12, FAT16, and probably the one you're most familiar with, FAT32.
Okay.
And each one kind of brought some improvements, like the number of files it could handle, how big those files could be, how much storage you could have in total.
So what were the limitations with the really early ones?
Well, FAT12, if we think way back, it was very limited. You're talking 32 millibit max, both file size and storage.
Oh.
Yeah. And then FAT16 was an improvement, but it was really FAT32 that became the standard for a while.
Oh.
But even then, the biggest file you could have was 4 gigabytes.
Oh, wow. That seems small nowadays.
It is. And even though the total size could be a bit bigger in certain situations,
Right.
that 4 gigabyte limit became a real pain, especially as you started having things like higher resolution photos, videos. Those files got big fast.
Yeah. 4 gigabytes is nothing these days.
So why was FAT32 so popular for so long? Because I know it's still used for some things, right?
Right. Even though it had those limitations, it worked on everything.
Yeah.
Windows, Mac. You could even plug it into some TVs, game consoles. It just worked.
Wow.
And that compatibility is why you still see it on those smaller USB drives, camera memory cards,
Okay.
things where you want to just plug it in and know it's going to work.
Okay, so FAT32, maximum compatibility, but maybe smaller devices. So then NTFS came along, right?
Yeah.
New Technology File System, I think it stands for.
Yes,
So this was meant to break through the limitations of FAT32.
that's exactly right. NTFS came out in 1993, and it was like, okay, those limitations are gone.
And the difference is insane. We're talking a theoretical file size limit of 16 exabytes.
16 exabytes. What even is an exabyte?
It is 1 million terabytes.
Okay, so it's basically unlimited for most people.
Yeah, for all practical purposes, it's unlimited. Same with the total storage it can handle, also in the exabytes.
Wow. So it's not just size, though, right? I know
No.
you were talking about journaling before. What is that, and why is that such a big deal?
Yeah, so journaling is huge for keeping your data safe. So with NTFS, it keeps this log, this journal of every change that's about to happen to the drive.
Okay.
So let's say your computer crashes or you lose power. NTFS can use that journal to rewind and make sure everything is consistent.
So you don't lose everything.
Exactly. It's like a safety net. It really reduces the risk of your files getting corrupted because without journaling, things are being written, something happens,
Right.
you're just left in this weird half-finished state. And your files could be gone, they could be damaged, who knows?
So NTFS, much safer if you're worried about your computer crashing or losing power.
Exactly.
Okay. NTFS also has those advanced features that FAT32 didn't, right? Like file permissions and stuff.
Yes, much more control with NTFS, like who can access a file, what they can do with it. You can make a file read-only, so it can't be changed, accidentally deleted.
Oh, right.
You can encrypt files for security.
Okay.
And all that stuff is why, Windows needs the main drive, the system drive, to be NTFS.
For security reasons, especially, I guess.
Yeah.
Makes sense. Now, the video did mention NTFS isn't always the best when it comes to, using it with other operating systems.
Yeah, that's true.
What's the deal with that?
NTFS, it's built for Windows.
Right.
And it's great at that. But other operating systems, well, it can be a bit tricky.
Okay.
Older versions of Windows might have problems.
Mm.
Macs, they can usually only read NTFS drives. You can see the files, you can copy them, but you can't edit them or save new ones directly without extra software.
Gotcha.
And some older media players, like, forget about it. They don't even recognize NTFS.
Oh, okay. So it's great for Windows, but maybe not the best if you're going to be sharing with other types of computers.
Right.
So that brings us to exFAT, Extended File Allocation Table. And this is what Microsoft came up with to kind of solve this problem.
Yeah. They released it in 2006,
Okay.
specifically for these bigger USB drives and memory cards.
Okay.
And they wanted to find a middle ground between FAT32, which was super simple,
Right.
and NTFS, which was very advanced.
Oh.
Okay, so it's less complex than NTFS, but it gets rid of that 4 gigabyte file size limit that FAT32 had.
Okay.
And it also has that massive theoretical limit of 16 exabytes.
Oh, wow. Just like NTFS.
Pretty much unlimited for most people. So yeah, if you want to move big files between Windows and Mac,
Yeah.
exFAT is a good choice.
Especially if you're working with like video files and stuff. I know the video mentioned the SG Card Association uses it.
Yeah, they use it for those SDXC cards, the ones that are bigger than 32 gigabytes,
Yeah.
because it can handle those huge video files.
Makes sense. So for compatibility, how is it compared to like NTFS and FAT32?
It's better than NTFS.
Okay.
Macs can read and write to it just fine. Most new Android devices support it too, so it's really good for people who are, using both Windows and Mac.
Yeah.
Linux, though, sometimes you might need a driver, but usually it's okay.
Okay, so XFT, good compromise, works on lots of different things.
Yeah.
Nice. Okay, so the video also talked about some file systems that are for other operating systems.
Mm-hmm.
Like Linux, they have that whole ext family.
Right. That's Extended File System, shortened to ext. First version came out in 92.
Oh, wow.
It's been around.
Yeah.
And it's had several versions. X2 was the standard for Linux for a long time.
Okay.
And then in 2001, X3 came out, and it had journaling, which we talked about, so that made it much more reliable. And now the modern standard is ext4.
Okay.
Came out in 2008, and it's even faster and can handle even bigger drives.
What kind of size limits are we looking at with extifs?
So ext4 individual files can be up to 16 terabytes. And the whole volume can be up to 1 exabyte. So not quite as big as NTFS or exFAT, theoretically,
Right.
but still more than enough for almost everyone who uses Linux.
Yeah.
And the key thing here is that if you're on Windows or Mac,
Right.
you can't read or write to X drives natively.
Oh, okay.
You need special software to do that.
Gotcha. So if you're mainly using Windows or Mac, you probably won't see those unless
Yeah.
you're using Linux.
Right.
What about Apple, though? Because they have their own file systems, too.
Yeah, they do. They have their own history. So you have HFS, the hierarchical file system, way back from 1985. That was for the classic macOS. But the limits were smaller. 2 gigabytes max file size, 2 terabytes volume limit.
Okay.
In 98, they moved to HFS plus SAW, so that's also known as HFS Extended or macOS Extended. And this one, it added journaling, just like NTFS and X3.
Right.
And the size limits got much bigger, up to 8 exabytes.
Okay.
And then more recently, 2017, they introduced APFS, the Apple file system. This one was really designed for the solid-state drives, the SSDs, that are so common now. Even better performance, more features.
Okay.
But just like with Linux, Windows can't understand these Apple file systems natively.
Yeah. It seems like generally each operating system has its own preferred file system.
It makes sense, right?
Yeah.
They design it for their own system.
Exactly. Now, the video also talked about this one called ZFS, the Z file system. And this sounded different, like it was a different approach to storage management.
Yeah, ZFS is interesting.
Yeah.
It combines a regular file system with something called a volume manager,
Okay.
which means it can actually manage all those hard drives and SSDs that are connected to your computer directly. So that means it can do things like RAID, which is a way of combining multiple drives for more storage or redundancy.
Right.
And it's also really good at preventing data corruption. So it's all about keeping your data safe.
So it's like built-in data protection, essentially.
Pretty much.
That's cool.
Yeah, it's mostly used on Linux, FreeBSD, and TrueOS right now.
Okay.
But there are people working on bringing it to Windows and Mac. Oh, interesting.
So we might see it more in the future.
That's cool. So, okay, this has been a great overview of all these different file systems, but practically, what advice would you give to our listeners? How do you choose the right file system for different things?
Right. Well, if we're talking about your main drive where your operating system lives,
Right.
just stick with what it recommends.
Okay.
So for Windows, that's NTFS. Most Linux, it's ext4.
Right.
And for macOS, it's either HFS Plus or APFS.
Makes sense. Keep it simple.
Exactly.
What about like USB drives and SD cards? Because we use those all the time for moving stuff around.
Right. So if it's a smaller one, like 32 gigabytes or less,
Yeah.
and you need it to work with a lot of different devices,
Hmm.
then FAT32 is still okay.
Right?
But just remember that 4 gigabyte file limit,
Yes.
if you're going to be working with bigger files,
Yeah.
or you have a larger drive, like anything bigger than 32 gigabytes, then exFAT is usually better.
Okay.
It works on Windows and Mac, so it's a good choice for most people. And what about those external hard drives or SSDs that people use for backups or, just to store more stuff?
Right. So if you're mostly using Windows, then NTFS is probably best. It's got all those features. It's reliable.
Okay.
But if you're switching between Windows and Mac a lot,
Right.
then exFAT is going to be more convenient. Just remember it doesn't have all the advanced NTFS stuff.
Gotcha.
You could use FAT32, but again, that 4 gigabyte limit.
Yeah, in that video we watched, the guy was talking about how he tried to unzip a big file on the FAT32 drive, and it just wouldn't work.
Right.
So, those limitations are real.
Yeah, you don't really think about it until you run into a problem.
Yeah. So how can people check what file system they're using on a drive? And what if they want to change it?
It's usually pretty easy to check. You can just right-click on the drive, go to Properties in Windows, or get info on a Mac, and it'll tell you right there.
Okay.
Now, if you want to change it, you have to reformat the drive, and this is important. That erases everything on the drive.
Oh, yeah. Back up your data first.
Absolutely. Make sure you have a copy of anything important before you reformat.
Yeah, good advice. So, as we mentioned at the beginning, this episode is sponsored by Stonefly, and they specialize in data resilience. And it makes me think that, with all this talk about file systems and how they can be limited or vulnerable, you really need to think about how you're protecting your data.
Yeah, that's a really important point. Choosing the right file system, that's important for how you use your data day to day, but it's just one part of keeping it safe.
Right.
You can still lose data no matter what file system you're using. Your hard drive could fail, you could accidentally delete something, software can have problems, there's ransomware.
Yeah, so many things can go wrong.
Exactly. So you need to think bigger. You need a real data protection strategy.
And this is where Stonefly comes in, right? They have a solution called Stonefly DR365V.
Yes.
Can you tell us about that? How does that help with all of this?
Yeah, DR365V is all about making sure you don't lose your data, and it uses a few key technologies to do this. One of the most important is immutable storage.
Immutable storage.
Yeah, immutable. It means that once you've written your data to the storage, it can't be changed. It can't be deleted, not even by someone who has admin privileges.
Okay.
So this is huge for protection against ransomware, because a lot of times what the attackers will try to do is encrypt your backups or just delete them completely.
Yeah.
But with immutable storage, they can't do that.
Wow, that's really cool. So it's like a super strong lockbox for your backup.
Exactly.
What else does DR365V do?
Another big one is air-gapped backup.
Okay.
So an air gap, that's basically like a wall between your backup data and your main network.
Okay.
So if there's an attack, it can't spread to your backup.
Oh, that makes sense.
It's like an extra layer of protection.
Yeah.
And Stonefly, DR365V, it's also a complete DR appliance. So that means it's a one-stop shop for backing up your data and then recovering it if something bad happens,
Okay.
like a hardware failure or a cyber attack.
So it's all about having a safe, separate copy of your data.
Exactly. And Stonefly's been doing this for over 2 decades. They really know their stuff. They've developed all these technologies to help businesses protect their data no matter what file system they're using.
That's really awesome. And actually, we're lucky enough to have a technical engineer from Stonefly here with us today to tell us a bit more about how this all works. Welcome to the show.
Thanks for having me.
So, we've been talking about file systems, but they don't really offer that much protection against, all the threats that are out there today.
Right.
So how does Stonefly DR365V help with that?
Yeah, so as you said, file systems are great for organization, but when it comes to data loss, you need something more. And that's what DR365V is designed to do. It creates these safe, isolated copies of your data, and it doesn't matter what file system you're using on your computer. So the immutable storage we offer, that's achieved using a special hardened operating system and what we call worm technology, which is write once, read many. It's kind of like imagine a CD. Once you burn something onto it, you can't change it.
Oh, right.
It's the same idea here. Your backups are locked in. Even if someone gets access to your system, they can't touch the backups.
So even with admin privileges, they can't mess with it?
Nope.
That's wild.
Yeah, it's really secure. And then air gapping, that's done in a couple of ways. We use network segmentation, so it's logically separated,
Okay.
and we have access controls. And in some cases, it can even be physically separated, so there's no way for like malware or hackers to reach your
Oh,
backups.
wow. That's really smart.
Yeah, and the DR appliance itself, it has all these features for backing up your data and then recovering it quickly. Like you can actually boot a virtual copy of your server right from the appliance if something
Oh,
happens.
that's really cool.
Yeah, so you can be up and running again in no time.
So all these things together, it really is like a complete data protection solution.
Exactly. And it works regardless of what file system you're using on your computers.
That's awesome. So it sounds like it's really important to think about like more than just the file system, right? Like you need this whole strategy.
Right.
So for our listeners who are, interested in this and want to learn more about keeping their data safe, I know Stonefly has a special offer this month.
We do. So right now we have our DR365V appliance. It comes with 70 terabytes of raw storage,
Wow.
which you can expand all the way up to 4 petabytes.
That's a lot of storage.
It is. And it includes all those features we talked about, the air gapping, the immutability. It also works with all the major backup software like Veeam, Rubrik, Commvault. It can do site recovery, full backup, disaster recovery. And we've got our object lockdown technology, which is specifically designed to stop ransomware. And all of that
Yeah.
for $7,995.
Wow. That's a great deal.
Yeah, we're really excited about it.
So for people who want to learn more about Stonefly or, check out this offer, where should they go?
The best place to go is our website, stonefly.com. We've got all the information there, and you can contact our team to learn more.
Awesome. And we'll put a link in the show notes too. So as we wrap up, it's clear that understanding file systems, it's important. It helps you make good choices, avoid problems, and get the most out of your storage.
Right.
But it's really just the foundation, right?
It is.
To really keep your data safe, you need a bigger plan.
Yeah. You need a data resilience strategy.
Exactly. So for our listeners, I'll leave you with this thought. Think about how you're protecting your data. Because it's valuable, right?
It is.
And there's so many threats out there.
So many.
So take the time to make sure it's safe. Yeah, maybe check out Stonefly DR365E, see if it's a good fit for you. Thanks for joining us on the deep dive. We hope you learned something today.
Yeah, thanks for listening.
We'll see you next time.